Welcome back to SQL Fundamentals. In lesson 1, we learned how SQL joins allow us to combine information from multiple tables to answer real business questions. We saw how the member, claim, and provider tables work together to give us complete picture of healthcare data. Today we are going to build on that foundation by learning one of the most important, most frequently used SQL command, the where clause. As a data analyst, you'll use the where clause almost every day because it helps you find exactly the information you are looking for. Imagine you are working as a data analyst for a health insurance company. Your database contains thousands or even millions of claim records. Now think about the kind of request your manager might make. They almost never want to see every claim in the database. Instead, they ask very specific business questions such as, show me all claims submitted by member 1001, show me claims where the amount is greater than $500, show me all claims submitted by Dr. Brown, so on and so forth. Notice the common pattern in each of these requests. We are not interested in every row in the database. We only want the rows that meet a specific condition. That's exactly what the where clause does. It filters the data and returns only the rows that match the criteria you specify. Rather than searching through thousands of records manually, SQL does the filtering for you in just a fraction of a second. Throughout this lesson, we'll continue using the same healthcare claim database from lesson 1. Since you are already familiar with the database structure, you can focus entirely on learning SQL concepts instead of trying to understand new data set. Let's take a quick look at the database shown on the slide. The members table stores information about health plan members. The provider table stores information about healthcare providers. And the center is the claim table, which connects members and providers while storing details such as claim amounts and service information. This claim table will be primary table. We'll work throughout this lesson today. By the end of this lesson, you'll be able to filter rows using numeric values, filter rows using text values, use comparison operators such as equals to, greater than, less than, and other common operators. Combining multiple conditions using AND operator and OR operator, and use parentheses to control how SQL evaluates more complex conditions. Before we begin, I would like you to remember one important idea. The where clause never changes the data stored in the database. It simply tells SQL which rows should be returned in the result set of a query. Once you understand that concept, you will understand the true purpose of the where clause. Now let us see exactly how SQL filters the data. Welcome to the heart of today's lesson. Now that we understand why we need to filter the data, let us see exactly how the where clause works. Take a look at the claim table on the left. Imagine this table contains thousands or even millions of insurance claims. Now suppose your manager asks, I only want to see claims greater than $500. Notice that they are not asking to see every claim in the database. They only want the claim that meet a specific condition. That's exactly where the where clause comes in. In this example, our condition is simple. Claim amount is greater than $500. Let us see what SQL does. Starting at the top of the table, SQL evaluates each row once at a time. Claim 5002 has an amount of $750, so it satisfies the condition. Claim 5004 has an amount of $1200, so it also qualifies. Now look at the remaining claims. 5001 only $250, claim 5003 is only $100, and claim 5005 is $300. Since none of these amounts are greater than 500, SQL simply skips them. As a result, only the two matching claims appear in the output table. Everything else is filtered out. This is why I like you to think of the where clause as the filter. Imagine you're pouring a water through a coffee filter. The filter allows only certain things to pass through, while everything else stays behind. The where clause works the same way. Only the rows that satisfy your condition make it into the funnel, and final result set. Now let us look at the SQL statement itself. Notice that where clause comes after the from clause. First we will tell SQL which table to search, then we tell SQL which rows we want to keep. Before we move on, I would like to emphasize one more important point. The where clause filters rows. It does not remove or modify columns, and it never changes the data stored in the database. The original data remains exactly as it was. The where clause simply controls which rows are displayed in the results of your query. With that foundation in place, we are ready to learn how to build different type of filters conditions using comparison operators. Now that we understand what the where clause does, let us solve our first real business problem. Imagine your manager walks over and says, I need to see every claim submitted by member 1001. This is very common type of request. Instead of looking at every claim in the database, they only want to see the claims for one specific member. Let us look at the claim table. Our attention is on the member ID column now because that is the field we'll use to filter the data. Our goal is simple. Find every row where the member ID is 1001. Let us scan the table together. First claim 5001 belongs to member 1001, so it matches our condition. The second claim belongs to member 1002, so SQL skips it. The third claim belongs to member 1003, which also does not match. Next we come to claim 5004. Once again the member ID is 1001, so SQL keeps that row as well. Finally, claim 5005 belongs to member 1002, so it is not included in the result. Notice that SQL is doing behind the scenes. It examines every row in the table and asks the same simple question. Is the member ID equal to 1001? If the answer is yes, SQL includes the row in the result. If the answer is no, SQL moves on to the next row. Now let us look at the SQL statement. Select star from claim where member ID is equal to 1001. The select statement tells SQL they want to return every column. The from clause tells SQL which table to search, and the where clause specifies the condition that determine which rows are returned. Notice the equal sign. The equal sign searches for exact match. Only rows where the member ID is exactly 1001 satisfies the condition. Every other row is excluded from the result. The query breakdown on the slide summarizes the purpose of each part of the statement, making it easy to understand how the query works from top to bottom. Before we move on, remember this important takeaway. The equals is equal to operator is used whenever you want to find an exact match. It is one of the most common comparison operators you will use as a SQL developer or data analyst. Now that you have seen how to search for an exact values, let us learn how to find values that are greater than or less than a specific number. Now that we have learned how to search for an exact match using the equal sign, let's make our queries even more powerful. Imagine your manager asks a different question now. Instead of requesting claims for one specific member, they say, show me every claim greater than $500. Notice that what different about this request? This time we are not looking for one exact value. Instead, we are comparing numbers to determine whether they satisfy condition. Let's look at the claim table. Our condition is straightforward. Claim amount is greater than $500. Now let us evaluate each claim together. The first claim is the amount of 250. Is 250 greater than 500? No. SQL skips that row. The second claim is 750. Since 750 is greater than 500, SQL includes that result. The third claim is $100, which does not satisfy the condition, so SQL skips it as well. The fourth claim is $1,200. Because 1200 is greater than 500, SQL keeps that row. Finally, the last claim is $300. Again, that does not meet our condition, so it is included. After checking every row in the table, SQL returns only the claims whose amounts are greater than 500. Now let us take a look at the SQL statement. Select star from claim where the claim amount greater than 500. The structure of the query should look familiar. The select statement specifies the columns we want to return. From clause identifies the table we are searching, and where clause defines the condition that each row must satisfy. The key difference from our previous example is the comparison operator. Instead of using the equal sign, we are using greater than operator. This tells SQL to compare every claim amount against the value, here it is 500, and return only those rows where the amount is larger. Let's also take a moment to review the comparison operators you will use most often. Equals finds an exact match, greater than finds a value larger than specified number, less than finds a value smaller than specified number, greater than or equal to includes values that are greater than or exactly equal to specified number. Less than or equal to includes value or less than or exactly equal to that specified number. Not equal to depend on the SQL database. It could be less than, greater than symbol, or exclamation and is equal to mark. That is not equal. So returns every value except the one you specify. Those comparison operators are used constantly in SQL. Whether you are analyzing healthcare claims, bank transactions, retail sales, employee records, or inventory data, comparison operators help you quickly identify the records that matter. Before we move on, remember this key idea. Comparison operators evaluate values. SQL then returns only the rows that satisfy the condition you specify. Now that we have learned how to filter numeric values, let's move on to filtering text values and begin building even more useful business queries. Now that we learned how to filter numeric values, let us learn how to filter text values. Database don't just store numbers, they also store names, cities, states, diagnosis, provider names, and many other type of text. The good news is that the where clause works with text values just as easily as it does with numbers. Now imagine your manager asks, show me every claim submitted by the Dr. Brown. At first, this seems like a simple request, but before we write the query, let's think about where the name Dr. Brown is exactly stored. Take a look at the provider table. Here we can see the Dr. Brown has provider ID 2002. Now look at the claim table. Notice that claim table does not store the provider's name. Instead, it stores only the provider ID. That's exactly why we learned joins in lesson 1. To answer this business question, SQL first joins the claim table with the provider table using the provider ID. Once those tables are connected, SQL can associate each claim with the correct provider name. Now we can apply our where clause. Our condition is where provider name is equal to Dr. Brown. Notice that Dr. Brown is enclosed in single quotation marks. That is because text values text value. When SQL evaluates the query, it checks each row after join and asks, is the provider name exactly Dr. Brown? If the answer is yes, SQL includes that rows in the result. If the answer is no, SQL skips it. After examining every row, only the claim submitted by Dr. Brown remains in the final results set. Now let us take a look at how the SQL statement works. First, SQL reads the claim table. Next, it joins with the provider table using the provider ID. Finally, where clause filters the results to include only rows where the provider name is Dr. Brown. Before we continue, remember one important rule that every SQL developer learns early on. Numeric values are written without quotation marks. Text values written inside the single quotation marks. Keeping this simple rule in mind will help you avoid many common SQL syntax errors. Now that we learned how to filter both numeric and text values, let's take a next step by combining multiple conditions using the AND operator and OR operators. Welcome back. So far, we have learned how to filter data using a single condition. For example, we filtered claims where the claim amount was greater than 500, and we also learned how to filter text values, such as claims submitted by specific provider, that's the Dr. Brown. But in the real world, one condition is often not enough. Business users frequently ask questions that require multiple conditions to be satisfied at the same time. Let's look at today's example. Our business question is, show me all claims that are paid greater than 500. Notice the word "and". That single word changes how SQL evaluates the data. When you use the "and" operator, every condition must be true for a row to be included in the results. Let's walk through the claim table together. The first claim has an amount of 250 and its status is paid. Status meets our first condition, but the amount is not greater than 500, so it does not meet. Since one condition fails, SQL exclude this row. Now look at the second claim. Amount is greater than 750, so it satisfies the amount condition. However, the status is denied. Again, only one condition is true, so SQL excludes the row. The third claim is paid, but its amount is $100. Once again, one condition fails, so the row is also excluded. Now let's look at claim 5004. It is paid and amount is $1,200, which is greater than 500. This time, both conditions are true, so SQL returns the row. Finally, claim 5006 also paid and amount is $800. Once again, both conditions are true and satisfied, so this row is included. Well, after evaluating every record, SQL returns only claims 5004 and 5006. Now let's take a look at the SQL statement. Select star from claim where status is equal to paid and amount is greater than 500. The query follows the same structure we have been using. Select statement tells to return every column. The from clause identifies the table to search. The where clause specifies the first condition and the second condition. Operator. Another condition that must also be true. Although SQL has its own internal query optimizer, you can think of the logic like this. First, SQL checks whether the status is paid. Then it checks whether the claim amount is greater than 500. Only rows that satisfy both conditions appear in the final result. The query breakdown on the side summarizes the purpose of each part of the statement. It is the most important idea to remember. Think of the AND operator as an intersection. Every condition must be satisfied. If a row fails even one condition, SQL excluded from the result. So you will use the AND operator constantly when writing business reports. For example, show me customers in California who spent more than $100. Show me employees in the sales department who were hired after 2023 year off. Show me products that are in stock and cost less than $50. In each of these examples, every condition must be true before a row is returned. In the next lesson, we will learn about OR operator, where satisfying either condition is enough for SQL included in the results. Welcome back. In the previous lesson, we learned how the AND operator works. With AND, every condition must be true before SQL returns a row. Now let us look at another logical operator that behaves very differently. The OR is OR operator. Imagine your manager asks the following question. Show me all claims that are paid or have an amount greater than $500. Notice that word OR. Unlike AND, OR operator is much more flexible. A row only needs to satisfy one of these conditions to be included in the results. Let's walk through the claim table together. Claim 5001. The claim amount is 250, so it does not satisfy the amount condition. However, the status is paid. Since one condition is true, SQL returns this row. Claim 5002, let's take that. this claim as an amount of 750, which is greater than 500, but the status is denied. The first condition is not met, but because the amount satisfies the second condition, SQL includes the row. Claim 5003, the amount is only 100, so it does not satisfy the amount condition. However, the status is paid. Again, the condition is true, so SQL returns the true. Row. Claim 5004, claim is paid and its amount is 1200. Both conditions are so, this row is returned. Claim 5005, the claim has an amount of 300 and status is denied. The amount is not greater than 500 and the status is not paid. Since neither condition is true, SQL excludes the row. Claim 5006, this claim is paid and its amount is $800. Both conditions are satisfied, so SQL returns the row. Claim 5007, finally, claim 5007 has a status of denied, but amount is $600, which is greater than 500. Even though status does not match, the amount does. Since one condition is true, SQL includes this row as well. After evaluating every row, SQL returns every claim that satisfies at least one of the two conditions. Now let us look at the SQL statement. So select star means all columns from claim where status is equal to paid or amount is greater than 500. The where clause contains two separate conditions. The first condition searches for claims whose status is paid. Second searches for claims with amount greater than 500. The or operator tells SQL that either condition is enough. A row does not have to satisfy both conditions. Meeting just one of them is sufficient to be included in the result. The query breakdown on the slide summarizes each part of the statement. Select statement returns every column. The from clause identifies the claim table. The where clause specifies the filtering conditions, and the or operator gives SQL an alternative path. If either condition is evaluates true, the row is returned. Let us finish with today's key takeaway. Think of OR as giving SQL multiple ways to qualify. If a row satisfies the first condition, the second condition, or both, it appears in the result. Only rows that fail every condition are excluded. This is why queries using OR operator typically return more rows than query using the AND operator. In the next lesson, we'll combine AND, OR, and parentheses to build more powerful SQL queries while controlling exactly how SQL evaluates multiple conditions. Welcome back. So far, we have learned how to use AND operator and OR operator individually. But what happens when we need to use both operators in the same query? That's where parentheses become extremely important. Let's look at today's business question. Imagine your manager asks, show me all claims that are paid and have an amount greater than 500 or was submitted by Dr. Brown. Notice that this request contains these three separate conditions. Claim must be paid, claim amount must be greater than 500, or the claim must have been submitted by Dr. Brown. At first glance, this may seem straightforward. However, if we don't organize these conditions correctly, SQL may evaluate them differently than we intended and return the wrong result. That is exactly why we use parentheses. Now look at the SQL statement. Select star from claim where parentheses begin, status is equal to paid, and amount is greater than 500, parentheses close. Or operator, provider name is equal to Dr. Brown. Think of parentheses exactly the way you learned them in mathematics. They tell SQL, evaluate this part first. Without parentheses, SQL follows its own order of operations, also known as operator precedence. That default evaluation order may not match the business logic you are trying to express in this query. The parentheses tell SQL to evaluate the end condition first. SQL begin by asking, Is the claim paid and is claim amount greater than 500? Only rows that satisfy both of these conditions pass the first test. Next, SQL evaluates the second condition outside the parentheses. It asks, was this claim submitted by Dr. Brown? Finally, SQL combines the two results. If either of the expression inside the parenthesis is true or the provider is a Dr. Brown, the row is returned. Let us walk through the claim table together. Claim 5001, the claim is paid, but the amount is only 250. Since the amount is not greater than 500, the expression inside the parenthesis evaluates to false. The provider also is not Dr. Brown because the neither part of the query is satisfied, so SQL excludes this row. Claim 5002, the claim is denied, so it is immediately fails the expression inside the parenthesis. However, it was submitted by Dr. Brown. Because the OR condition is true, SQL includes a row. Claim 5003. This claim is paid, but the amount is only 100. It also was not submitted by Dr. Brown. Neither condition is satisfied, so SQL excludes it. Claim 5004. This claim is paid. Its amount is $1,200 and it was submitted by Dr. Brown. It satisfies both parts of the query. Naturally, SQL returns the row. Claim 5005, the claim is denied. Its amount is for $300 and it was not submitted by Dr. Brown. Neither condition is true, so SQL excludes it. Claim 5006, this claim is paid and amount is $800. This satisfies the expression inside the parenthesis. Even though it was not submitted by Dr. Brown, the first part of the query is already true. SQL returns the row. Finally, claim 5007, this claim is denied, so it fails the first expression. However, it was submitted by Dr. Brown. Because of the OR condition is satisfied, SQL includes them. Now, let's look at how SQL evaluates this query. Notice three-step diagram. Step 1, SQL evaluates everything inside the parenthesis first. In this case, it determines which row satisfies end condition. Steps 2, SQL evaluates OR condition by checking whether the provider is a Dr. Brown. Step 3, SQL combines the result from the both evaluations and returns every row that satisfied either part of the query. This evaluation order is exactly why parentheses are so important. Without parentheses, SQL applies its own rules for operator precedence. Although SQL gives A and D higher precedence than OR, relying on those rules can make your queries harder to understand and easier to misinterpret. Using parentheses removes any ambiguity. It makes your intent crystal clear, not only to SQL, but also to anyone who reads your code later. Let us finish with today's key takeaway. Whenever you combine AND and OR operators in the same query, make it a habit to use parentheses. They use SQL evaluates your conditions exactly as intended, improve readability, and help prevent subtle logic errors. As your SQL queries become more advanced, you will find that parentheses are one of the simplest and most valuable tools for writing clear, reliable, and professional SQL. We have covered a lot in this lesson, so let us take a few minutes to review the key concept we have learned. The where clause is one of the most important tools in SQL because it allows us to retrieve only the data that answers a specific business question. Instead of searching through thousands or even millions of records, we can tell SQL exactly what we are looking for. Throughout this lesson, we have built that skill one step at a time. We began with exact match using the equal operator to find specific values such as all claims submitted by member 1001. Next, we learned about comparison operators including greater than, less than, greater than or equal to, less than or equal to, and not equal to. These operators allow us to compare values and return only the rows that satisfy our conditions. After that, we'll learn how to filter text values. One important rule to remember is that text values must always be enclosed in single quotation marks. We then introduced A and D AND operator. Remember that AND requires every condition to be true. Even one condition evaluates to false, SQL excludes that row from the result. Next, we explored OR, R operator. Unlike AND, R operator is more flexible. A row is written if at least one condition is true. If both conditions are true, that's perfectly fine. The row still included. Finally, we learned how to use parentheses. Parentheses let us control the order in which SQL evaluate conditions. Whenever you are combining and are in the same query, using parentheses make your logic easier to understand, helps prevent unexpected result. It's one of the best habits you can develop as a SQL programmer. Now take a look at the examples on the right side of the slide. Notice how every business question translates directly into where clause. Managers don't ask for SQL syntax. Instead, they ask questions like, show me claims over 500, show me paid claims, show me claims submitted by the Dr. Brown. As data professionals, our job is to translate those business questions into SQL queries. That's exactly what you have been practicing throughout this lesson. It's also worth remembering a few common beginner mistakes. Many new SQL users forget to place quotation marks around the text values. Others accidentally use the wrong comparison operator. Some forget to use parentheses when combining and and R operators. And, and perhaps the biggest misconception is thinking that the where clause changes the data. It does not. The where clause simplifies filters the rows written by your query. The data stored in the database remains completely unchanged. If you remember only 3 ideas from today's lesson, let them be: the where clause filters rows, not columns. It never changes or deletes the data. It only determines which rows are returned. Combining AND, OR, and parentheses allows you to answer increasingly complex business questions with confidence. Before we finish, I would like to leave you with one professional tip. Experienced SQL developers always write their queries to be clear, readable first. Once the query is correct, they focus on making it faster or more efficient. Readable SQL query is easy to debug, easy to maintain, and much easier to teammates to understand. Congratulations on completing lesson 2. You can now filter exact values, compare numeric values, search for text values, combine conditions with AND, broaden your results with OR, and control complex logic using parentheses. These are fundamental SQL skills that you will use in almost every database project, regardless of the industry. In lesson 3, we'll build on everything you have learned today by introducing order by clause. You will learn how to sort your query results from highest to lowest alphabetically, by date, and much more. Thank you for watching and congratulations on reaching another milestone in your SQL journey. You are making excellent progress. Every lesson adds another essential skill, and you are well on your way to writing professional SQL queries with confidence. I will see you in lesson 3. Happy learning!